of leaf area density on outdoor thermal comfort for commercial urban environments.
A very good afternoon to all of you. And here I would like to present my research on investigating thermal performance of leaf area density on outdoor thermal comfort for a commercial built environment, a case of Bhopal. India has been facing extreme heat conditions and has affected the life of its people to conduct their daily activities adversely. Heat is also considered as the silent killer. Many intergovernmental organizations, national bodies, and research have identified that human activities are warming the environment and it has led to physiological stress. It has led to exertional heat illness. And therefore, it is important to provide thermal comfort to all the people who are using it, all the stakeholders who are involved. And to do that, it is important and necessary for thermal comfort assessment of our outdoor areas. Heat stress risk is generally declared as when the temperature goes more than 440 degrees of variation and a variation of 4.5 degrees above normal. Now, extreme thermal discomfort occurs when the temperatures are high as well as the humidity is high. Therefore, several initiatives have been taken by central and the state government for its mitigation. Heat action plans are being prepared by each state, district, and at city level to respond to the heat stress risk, which consists of several short term and long term goals. Now, here is a table which shows the action plans and the associated measures. We are particularly interested in the nature based measure, which has both long term and short term actions. And the two actions which this study will focus on is enhancing the green cover and providing shade. Now, before we look at the progressive picture of these initiatives being able to tackle the challenge of heat stress, I would like to take a moment and draw your attention to how professionals in practice, especially the landscape architects, the urban designers, and planners, approach to tree planting. So it has all started with an exotic collection and arrangement of plant species for a visual appeal. Later, we realized that the maintenance of these vegetation is a very huge task, and therefore we started looking at site suitability, we started looking at management. Several environmental challenges have started, have now changed the way the planting actually occurs. And one of the ways is through an ecological approach where people as well as biodiversity are being prioritized for the vegetation that is being chosen. Another study, the climate study of succession, which is being used for planting an entire plant community rather than individual species, and they are set in an. There's these species are identified based on the biogeographic location, and then they are broadcasted into soil. The contemporary designers in the urban areas are opting for naturalistic plantings and which are scientifically taking communities and they are planted in the urban areas. They are being tested in the urban areas and not creating wild forests but creating wilderness in the cities. Now, one of the designer, which is James Hitchmont, he had derived a five-step process for tree plantation or planting vegetation. And the five-step process includes developing a strategy, identifying a list of plants to your site, accessing which are the micro locations, how will it fit to it, looking for whether these species are available nearby. However, McPherson in his study indicates that the future, if you have to design for the future, the species have to be climate ready. And he has come up with a six-step process which includes future climate modeling as in the beginning of before we identify the plant list. So, according to this process, the plant lists are gathered from experts. They are being modeled or simulated using some modeling tools. Then they are broadcasted, monitored, and the evidence-based learnings are then being used for should be used for the future practices. When we look at India and its planting selection, tree selection guidelines, we find that it is still very aspirational in nature. It talks about the qualitative aspect of controlling pollution, ameliorating climate, controlling erosion, and being aesthetically pleasing as well. But here we are not, we still lack in having a scientific basis for tree selection, especially in the urban design. We are in need of being very accurate and very strategic to actually help in reducing the thermal discomfort. There is no doubt that trees have impact on microclimate. Several studies have talked about solar attenuation, evaporative cooling, lowering air temperatures. Uh, Many studies have indicated the extent of improvement in quantifiable terms in degrees in Celsius on how can tree species and its clusters impact the thermal variables as well as the thermal comfort indices. Therefore, it all boils down to one important component or morphological property of a tree, which is its leaf area density, which governs the extent to which the species will help in regulating the microclimate. The aim of this study, therefore, is to study about the impact of tree morphological attribute on thermal comfort. The methodology followed here includes field data collection, climate modeling using NVMet 5.0. The field data was correlated with simulated data, and quantification of thermal discomfort reduction potential was actually drawn. For the field survey, several devices like WBG meter and anemometer and spherical densiometer was used. The database used fed for NPMet is mentioned in the table. We have further developed several scenarios based on LEDs, and LED 3 and LED 6 with varying coverage have been considered. The study area is chosen in Bhopal, which and the commercial area of Bhopal, where the extreme summer temperatures almost soar up to 44 degrees, and the vegetation over here present is currently dry deciduous. Therefore, the trees that have been proposed for simulation are also deciduous trees. It is a multi-purpose ground which have been used for fairs, festivals, organizing gatherings for the commercial street. Both cases, the base case as well as iterated case with completely filled with trees have been shown. Here the tree that has been considered is a medium sized tree which is 10 meters in diameter and 15 meters in height, and the varying coverage has been assessed from full coverage to half coverage to a quarter coverage. The quantification has been worked out by looking at the difference that has been observed from the iterated case to the base case in the thermal variables as well as thermal comfort index, that is PET. A negative value indicates higher reduction in temperature from the base case, and the magnitude of discomfort reduction was affected by the vegetation strategies that are used. The three ways in which comparisons have been made are by comparing the LEDs 3 and 6, by looking at the different locations in which the temperatures or thermal indices vary, by looking at the difference in full coverage and the half coverage. Now, this entire table consolidates the result that results on the basis of LEDs. So there are two tables. The top table is about LED 3 and its impact on air temperature, PET, and MRT. And similarly, the table below. So ultimately, this indicates that both LED 3 and LED 6 have helped in reducing air temperature, mean radiant temperature, and PET. However, the benefit of using LED 6 is that it is able to control the temperature for a longer duration. The major benefit of using LED 6 over LED 3 is that it reduces MRT significantly, and therefore the PET also gets reduced. And this is especially during the afternoon hours, which are very, very uncomfortable. However, after sunset, both the LEDs are responsible for increasing the temperature, but in case of LED 6, the increase is not very significant. When we look at the comparative analysis of the distribution of trees between full coverage and half coverage, we realize that there is a very less significant difference between the coverage density within the same LED. This indicates that thermal discomfort will not change if number of species are being changed from at least from a full coverage to half coverage. We look at the same table, but now this has been categorized on the basis of thermal indices. For example, change in air temperature, change in MRT, and change in PET. This indicates, the air temperature change indicates that both LED and LED6 have reduced the air temperature significantly, but the difference between the southern edge and the northern edge is very high. In case of LED 3 and LED 6, it helps in reducing mean radiant temperature, and full coverage shows maximum variation as compared to the half coverage. It is interesting to know that the difference between northern and southern mean radiant temperature within the same LED remains negligible. Ultimately, these results indicate that LED 6 are more effective in regulating the thermal discomfort. Currently, India is the fast-growing economy with high population, and 50% of the population will be living in 2047 in the urban areas. With such increase, the future plan for governed for 2047 is still based on governed by the vague idea of increasing tree cover within the city, random plantation drives, and replacement of indigenous species. So it is the question that, are we climate ready? Are the decision makers like us who are practicing every day ready or equipped to deal with the extremities of the future? So this is where I end my presentation. Thank you.
Okay, just time for one question.